In this video, we are going to prove the relationship between the inverse trigonometric functions. So now, let's prove the relationship between cosec inverse of x equals sine inverse of 1 over x. So, let y to be equal to cosec inverse of x. It implies that cosec y is equal to x. So now cosec y is the same as 1 over sine y, and that is equal to x. So it implies that sine y is equal to 1 over x, and therefore y is equal to sine inverse of 1 over x. So y is the same as cosec inverse of x, and therefore cosec inverse of x is equal to sine inverse of 1 over x. Let's also prove this relationship, which is sec inverse of x is equal to cos inverse of 1 over x. So let's let y to be equal to sec inverse of x. So it implies that sec y is equal to x. Sec y is the same as 1 over cos y. So 1 over cos y is equal to x. And therefore cos y is equal to 1 over x. So y is equal to cos inverse of 1 over x. Y is the same as sec inverse of x, and therefore sec inverse of x is equal to cos inverse of 1 over x. So we have established two proofs. That is, the first one is cosec inverse of x is equal to sine inverse of 1 over x. And then we have also established that sec inverse of x is equal to cos inverse of 1 over x. Now, using this, let's differentiate. How do we differentiate cosec inverse of x? So to differentiate cosec inverse of x, we know that cosec inverse of x is equal to sine inverse of 1 over x. So d dx of cosec inverse of x is the same as d dx of sine inverse of 1 over x, because we have already established this relationship. Now, remember that we said that d dx of sine inverse of g of x is equal to 1 over square root of 1 minus g squared of x, then g prime of x, from our previous lesson. If you don't understand why this is so, then I have put a link to my previous video on the how to differentiate the inverse trig functions in the description, so you can watch that video before watching this video. So now, how then do we go about this? So the first thing is to find g of x. So you can see that from here, g of x is equal to 1 over x. So let's find g prime of x. So g of x is equal to 1 over x. And then g prime of x will be equal to, if you differentiate 1 over x, you are going to get minus 1 over x squared. So now we can then take it and say that d dx of sine inverse of 1 over x is equal to 1 divided by square root of 1 minus. Now, g squared is the same as 1 over x squared, so 1 over x squared. Then times g prime of x, which is minus 1 over x squared. So this is equal to 1 divided by square root of. Now, 1 over x squared is the same as 1 squared over x squared, which is 1 over x squared. So this will become 1 minus 1 over x squared, then times minus 1 over x squared. This is equal to minus 1 over, then this x squared will come down, x squared, then square root of, now this will become x squared minus 1 divided by x squared. But now we know that absolute value of x times absolute value of x is equal to x squared. So because absolute value of x, whether negative or positive, will throw out a positive number. And if we multiply two positive numbers, we are going to get the square of the positive number. So therefore, this x squared, we can write it as absolute value of, so this becomes minus 1 divided by absolute value of x times absolute value of x, then square root of x squared minus 1. Now if you find square root, remember that square root of a over b is equal to square root of a divided by square root of b, and therefore square root of x, remember that if you find square root of a number, you cannot get a negative number, else you are running into the imaginary numbers. So this will also throw out absolute value of x. So this will be divided by absolute value of x, because x cannot be negative. So you see that this absolute value of x will cancel this absolute value of x, and at the end of the day we are going to get minus 1 divided by absolute value of x, square root of x squared minus 1. So using that same understanding, let's differentiate sec inverse of x. So what is d dx of sec inverse of x? But remember that we have already established that sec inverse of x is equal to cos inverse of 1 over x. So d dx of sec inverse of x is equal to d dx of cos inverse of 1 over x. So therefore, now remember that we have said that d dx of cos inverse of g of x is equal to minus 1 divided by square root of 1 minus g squared of x times g prime of x. So now what we need to do in this case is to find g of x. So we can see that g of x is equal to 1 over x, and therefore g prime of x is equal to minus 1 over x squared. d dx of cos inverse of g of x is equal to minus 1 over square root of 1 minus g squared of x, which is 1 over x squared, then times g prime of x, which is minus 1 over x squared. So this is equal to, now minus 1, they will cancel out, so it becomes 1 divided by x squared times square root of 1 minus 1 over x squared, and this is equal to 1 divided by, now x squared can be written as absolute value of x times absolute value of x, then square root of, now this can also be written as x squared minus 1 divided by x squared, and this is equal to 1 divided by absolute value of x times absolute value of x, then square root of x squared minus 1 divided by absolute value of x, so that this absolute value of x can cancel this one, because if you find the square root of a number, you cannot get negative, so it has to always take on positive values. So at the end of the day, this will be equal to 1 divided by absolute value of x times square root of x squared minus 1. And at the end of the day, let me write it here. d dx of sec inverse of x is equal to 1 divided by absolute value of x, square root of x squared minus 1. So how will we differentiate cot inverse of x? Now, to be able to do this, let me write a very important identity. Cot inverse of x is equal to pi over 2 minus tan inverse of x. Now, I'll prove this later on in the video, but let's just use it. I'll later prove this identity. So it implies that to differentiate cot inverse of x, we can just say it is equal to d dx of pi over 2 minus tan inverse of x. So now, if you differentiate pi over 2, it is 0. So this becomes minus d dx of tan inverse of x. But remember that we said if you differentiate tan inverse of x, you are going to get 1 divided by 1 plus x squared. So if you differentiate d dx of tan inverse of x, you will get this. But there is a minus sign here. So all of this times minus. And therefore, this will be equal to minus 1 divided by 1 plus x squared. Now, there are some very important identities that we want to prove. The first one is sine inverse of x is equal to pi over 2 then minus cos inverse of x. How do we prove this identity? Let's rewrite this as sine inverse of x then plus cos inverse of x is equal to pi over 2. Now let's let y to be equal to cos inverse of x. It implies that cos y is equal to x. Now remember that the cos function is the range of values of that y can take is between 0 and then pi. This is the region in which the cos inverse function is defined. So y is greater or equal to 0, but less than or equal to pi. Now let's multiply through by minus 1. If you multiply 0 by minus 1, you are going to get 0, less than or equal to. If you multiply y by minus 1, you get minus 1. If you multiply pi by minus 1, we are going to get minus pi. Nonetheless, because we have multiplied by minus 1, we need to change the sign. So this is not correct. The actual thing is minus pi is less than or equal to minus y, which is less than or equal to 0. Now let's add pi on 2 to every aspect of this inequality. So pi on 2 minus pi less than or equal to pi on 2 minus y less than or equal to 0 plus pi on 2. So it implies that pi on 2 minus pi is the same as minus pi on 2. So minus pi on 2 is less than or equal to pi on 2 minus y, which is less than or equal to pi on 2. So now, having established this, remember that the equation, we had sine inverse and cos inverse. So now, let's let f of x to be equal to sine inverse of x. So f of x is equal to sine inverse of x. What is f prime of x? F prime of x is equal to 1 over square root of 1 minus x squared. But remember that the range of values for which f prime of x will exist is between minus 1 and then 1. You see that If you differentiate sine inverse of x, you are going to get f prime of x equals 1 divided by square root of 1 minus x squared. But this is an increasing function in this interval. So since f prime of x is greater than 0, it implies that f of x is strictly increasing. So since f of x is strictly increasing, then by the mean value theorem, we know that f of x is greater or equal to f of minus x, but less than or equal to f of 1, because this is the interval of f of x. Remember that by the mean value theorem, the function must be differentiable on the open interval, and then it must be continuous on the closed interval. So what then it means is that now sine inverse of x is greater or equal to sine inverse of minus 1, but less than or equal to sine inverse of 1, because f of x is equal to sine inverse of x. So sine inverse of x. Now, what is sine inverse of minus 1? Sine inverse of minus 1 is minus pi on 2. And then sine inverse of 1 is pi on 2. So now, look at this. We are having minus pi on 2 less than or equal to pi on 2 minus y less than or equal to pi on 2. And it is the same here. Minus pi on 2 less than or equal to sine inverse of x, which is less than or equal to pi on 2. So you can see that this one, let's say this is equation 2 and this is equation 1. Equation 1 and equation 2 are equal. So what it means is that pi on 2 minus y is equal to sine inverse of x. So now, pi on 2, what did we say y was? Y is equal to cos inverse of x. So minus cos inverse of x is equal to sine inverse of x. And then this implies that sine inverse of x is equal to pi on 2 minus cos inverse of x. And that is exactly what we were supposed to prove. So let's prove this identity, which is cos inverse of x plus cos inverse of minus x equals pi. Now, let's let y to be equal to cos inverse of minus x. It implies that cos y is equal to minus x. Now, but we know that for the cos inverse function, y can only be greater or equal to 0, but less than or equal to pi. Now, let's multiply through by minus 1. So 0 times minus 1 is 0. Less than or equal to minus y, but less than or equal to minus pi. Since we multiply through by minus 1, then we need to invert the signs, and therefore minus y is greater or equal to minus pi, but less than or equal to 0. So now let's add pi to all the terms of the inequality. So it becomes pi minus pi less than or equal to pi minus y less than or equal to 0. So pi minus pi is 0, less than or equal to pi minus y, which is less than or equal to 0 plus pi is here, so here is pi. Now let's let f of x to be equal to cos inverse of x. Now what is f prime of x? F prime of x, if you differentiate the cos inverse function, you get minus 1 divided by 1 minus x squared. But that is true within the open interval 1 and minus 1 and 1. But you can see that within this interval, f prime of x is always going to be less than 0. If f prime of x is less than 0, then it implies that f of x is strictly decreasing. And what is a decreasing function? A decreasing function means that the image of the smaller value is bigger than the image of the biggest value. And therefore, what it means is that f of x within this closed interval is greater or equal to f of 1 but less than or equal to f of minus 1. F of x is the cos inverse function. So cos inverse of 1 is less than or equal to cos inverse of x, which is less than or equal to cos inverse of minus 1. Now, what is cos inverse of 1? Cos inverse of 1 is 0, which is less than or equal to cos inverse of x. And this is also less than or equal to cos inverse of minus 1 is pi. Now, you can see that this one, 0 is less than or equal to pi minus y, which is less than or equal to pi. Here, cos inverse function, 0 is less than or equal to cos inverse of x, which is less than or equal to pi. It implies that pi minus y is equal to cos inverse of x. Now, what is y? Y is the cos inverse of minus x. So pi minus cos inverse of minus x is equal to cos inverse of x. So this implies that cos inverse of x, then if you bring this one here, plus cos inverse of minus x is equal to pi. Now let's also prove that cot inverse of x plus tan inverse of x is equal to pi on 2. Let's prove this identity too. So let's let y to be equal to tan inverse of x. It implies that tan y is equal to x. Now, tan y is equal to cot into bracket pi over 2 minus y. Now, let's first finish the proof, then I'll prove why this is true. Notwithstanding, we said tan y is equal to x, so it implies that cot pi over 2 minus y is equal to x. So therefore, pi over 2 minus y is equal to cot inverse of x. And therefore, y is the same as tan inverse of x. So pi over 2 minus tan inverse of x is equal to cot inverse of x. And therefore, cot inverse of x and plus tan inverse of x is equal to pi over 2. Now, why is this identity true? Let's prove that identity. So we want to prove cot into brackets pi on 2 minus y. I will know that cot pi on 2 minus y is the same as cot is 1 over tan. So if you invert tan, you are going to get cos pi over 2 minus y divided by sine pi over 2 minus y. Now, this is equal to cos pi over 2 minus y is the same as cos pi over 2, then cos y, then plus sine pi over 2 sine y divided by sine pi over 2 minus sine y is the same as sine pi over 2 cos y, then minus cos pi over 2 sine y. Now, what is cos pi over 2? It's the same as cos 90. Cos 90 is 0. So this is equal to 0. Then sine pi over 2 is sine 90, which is 1. So plus 1 times sine y is sine y. Then divided by sine pi over 2 is 1. 1 times cos y will give cos y. Then cos pi over 2 is 0. And so this will be minus 0. So at the end of the day, this is equal to sine y divided by cos y. And sine y divided by cos y is the same as what? Tan y. So therefore, it is true that tan y is equal to cot pi over 2 minus y. Now, let's also prove this identity, which is cot inverse of x plus cot inverse of minus x is equal to pi. So how do we prove this identity? So now let's let y to be equal to cot inverse of minus x. So it implies that cot y is equal to minus x. Now, from trig identities, cot pi minus y is equal to minus cot y. Now, this cot y equals minus x can also be written as minus cot y is equal to x. Now, I'll prove why this is true. So let's first finish with proving the identity, and then I'll come and prove this relationship. Now, so this implies that cot pi minus y is equal to x, and therefore pi minus y is equal to cot inverse of x. So now y is the same as cot inverse of minus x. So pi minus cot inverse of minus x is equal to cot inverse of x, and therefore cot inverse of x plus cot inverse of minus x is equal to pi. Now, why is this identity true? So we want to prove that cot pi minus y is equal to minus cot y. Now, we know that cot is the same as 1 over tan. Therefore, cot pi minus y is the same as cos pi minus y divided by sine pi minus y. So, cos pi minus y is the same as cos pi cos y, then plus sine pi, then sine y divided by sine pi minus y is sine pi cos y, then minus sine y, then cos pi. So this is equal to cos pi is the same as minus 1. So minus 1 times cos y, it becomes minus cos y. Then plus sine pi is the same as sine 180, which is 0. So plus 0. And then divided by sine pi is the same as 0. So 0, then minus sine y. But cos pi is minus 1. So it becomes minus sine y. So this is equal to minus cos y divided by, now minus sine y is the same as sine y. And cos y divided by sine y is cot. So this becomes minus cot y. So therefore, it is true that cot pi minus y is equal to minus cot y.